Welcome back, everyone. Today I'll be doing homogeneous functions. Let's get started. This is a function of x and y, and it's of degree, or some persons will say order k. And it's usually the fact that we multiply both x and y by t. Then after factoring out t, we see that t is raised to some power, which is k. K represents a number, and we consider this to be the order or degree of this homogeneous function. Now, when we factor out t raised to some power, if we're getting the original function, then that tells us that the function is homogeneous. For example, I have a function of x and y, x to the fourth plus y to the fourth, and I need to show that it's homogeneous. So for it to be homogeneous, it means that I need to multiply the coordinates x and y by t, and when I multiply x to the fourth, it's going to be tx raised to the power fourth plus y being ty raised to the power fourth. This is going to be raised to the power fourth. All of this is raised to the power fourth. So I will have t to the fourth, x to the fourth, plus t to the fourth, y to the fourth. Then I factor out t to the fourth. And when I factor it out, I'll be left with x to the fourth plus y to the fourth. So what we're saying is that when you factor out t raised to some power, if the bracket has the original function, which is f of xy, then we can say it is indeed homogeneous. And the 4 represents the order, or we like to say degree. So the order is 4, or the degree is equal to 4. Now the next question, we have f of xy equal x cubed plus y cubed minus 3. Determine if this is a homogeneous function. So once again, wherever I see x and y, I will be replacing x with tx, and I'll be replacing y with ty. So here is x and here is y. So I will have tx cubed plus ty cubed. There is no x or y on the 3, so we'll leave it as minus 3. So this is t cubed x cubed plus t cubed y cubed. There is no x or y on the 3, so we have minus 3. And now we factor out t cubed. That's the next step. So I factor out t cubed here, and I'm left with x cubed plus y cubed minus 3 on the outside. If you look where I factor out t cubed, it's not the same as the original. Let's look at the difference. When we factor out t to the fourth, we're able to see the function xy, which is x to the fourth plus y to the fourth. That's what it's saying. When I factor out t raised to the power, I should be seeing the original function. In this case, that's not the case because I factor out t cubed, and what you're seeing left is x cubed and y cubed. The minus 3 is on the outside, so that is why we will say it's non-homogeneous. So in this case, this is a non-homogeneous function. Now the final one that we have here to show that it is homogeneous. And we have x to the 7 minus y to the 7 all over x squared plus y squared. So the rule still applies where we multiply x and y by t. So our new x and new y will be tx and ty. So where I have x to the 7, I will replace it to be tx to the 7. And where I have y to the 7, I'll replace it with ty to the 7. In the denominator, I will have tx all square plus ty all square. Now, where I have tx all to the 7, it becomes t to the 7 x to the 7 minus t to the 7 y to the 7 all over t square x square plus t square y square. Now, I am going to factor out t to the 7, and when I factor out t to the 7 in the numerator, I have x to the 7 minus y to the 7. And in the denominator, I can factor out t squared, so I'm left with x squared plus y squared. Now I can reduce this to give me t to the 5th. So by right, what I have here is t to the 5th and then x to the 7 minus y to the 7 all over x squared plus y squared. So I'm able to see that this is indeed homogeneous because this is the original function f of xy, and my order or degree is 5. Thanks for watching, guys. Don't forget to like and subscribe to my channel. And if you have more questions, you can leave a comment below.